Welcome. This is the Cisco CCNA3-ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 10, Network Management. Alright, so in this lecture we're looking at device discovery using both CDP, LLDP. We're going to be looking at some management protocols like NTP, SNMP. We're going to be looking at how to work with Syslog. We're going to be looking at file maintenance on both routers and switches. And we're going to end with some basic iOS image management. So let's jump right on in with network discovery using CDP. First of all, CDP is Cisco Discovery Protocol. It is a Cisco proprietary Layer 2 protocol which essentially basically just helps identify Cisco products. And how does it do this? It will send periodic CDP advertisements to connected devices, and basically these advertisements will share information about the type of device that's being discovered, the name, the number, and the types of interfaces, things like that. The goal here is to share basic information about the devices. So for Cisco devices, CDP is enabled by default because it's a Cisco device. How we can verify is show CDP. The interesting part is to turn it off per interface. We could do a no CDP enable in the interface configuration mode. So let's say we want to get rid of it underneath gig 01. Navigate to the interface, disable it. And if let's say you want to disable CDP as a general, you would be disabling CDP. If we want to be specific, we would do a no CDP run at the global configuration, and that would be the disable portion of it. How do we see the details? We could be doing a show CDP neighbor, and it will give you the device ID, the interface, the hold time, the platform, and the port that it's associated with. So if we want to look at specific details, you'd be a show CDP neighbors, and you'd tack in the detail command there as well. We have a lab covering how to do this using CDP. We actually have multiple labs in this chapter covering each one of these major areas. Next is using the link layer discovery protocol. If you've ever used Windows 7 or above, LLDP is there. It's a vendor-neutral neighbor discovery protocol, very similar to CDP, but it's more than just for networking devices. Though, in this example, we're focusing on networking devices. This protocol will advertise its identical and capacity to other devices, and it will receive the information from a physical connected layer 2 device. Again, we have to understand that both CDP and LLDP are layer 2 functionality. How do we configure it? Well, we have to do a little bit more with our LLDP. We actually have to navigate to the global configuration and the run command. This basically will allow us to enable it globally. To disable it, we would do no LLDP run, again from the global configuration. If we want to configure a specific interfaces, we'd have to configure both transmit and receive sections separately. We do that by navigating to the interface, going LLDP transmit, LLDP receive, and that ensures our transmission and our receiving. And they are these commands right here underneath our interface. How do we verify? Show LLDP neighbors, just like with CDP. If we want more specific details, we will be doing a show LLDP neighbors detail, just like CDP. Again, they're very similar in functionality. And again, we have a lab. This time we're looking at both CDP and LLDP. Next is going to be our network time protocol, time functionality. So if we want to sync time and calendar services, we're going to be using the network time protocol, NTP. We've talked about this in earlier sections, earlier videos, and earlier content, but again, time plays a huge role, especially when we are trying to synchronized like log management. So being able to set the time accordingly is extremely important. You can manually set the clock and date per device. However, if you manually do it, if the devices run a little slower, a little faster, the synchronization of the time can be off. So as the network grows, it definitely becomes more difficult. So a better solution is to use NTP and to set up network synchronization so that the time management is set to an NTP server. This will provide a consistent time setting regardless of the device. NTP uses UDP port 123. So how does this work? NTP uses a hierarchy system for time resources. Each level in the hierarchy is called a stratum. The stratum level is defined as the number of hops counting from the authoritative source, and a synchronized time is distributed across the network. So, normally the source, it could be a central time manager, it could be a Google time management server, it could be a government track time server. It really just depends. And then how many hops away from that would tell you how far you are away from the source. There are a hop count of 15 possible, so the lowest stratum number is 16. Normally you don't want it to be too far away from the stratum main groups. So normally we have a stratum 0. That's the authoritative time source. It has the highest precision time. We have a stratum 1. Basically, these devices directly connect to the authoritative time source, and they act as the primary network time. Anything less than stratum 2 are basically connected to stratum 1s for their time. Realistically, most government organizations, or like time management, time and TP, all of those are set to be a stratum 1. We users will connect to them, so we could be a stratum 2 or 3 or lower. If we are using a reference in TP, for example, we may connect to a time server management server that connects to a different time management server that connects to a different, and then connects to a different. That's how we can get the different stratums. So we may not be, number 2. We may be number 8 or number 9. But all of them sync back to a stratum 1, which connects back to a stratum 0. How do we verify? Well, from the exec mode, we can do a show clock detail, and that will give us our time. How do we configure an NTP server? Pretty straightforward. From the global configuration, NTP server, type in the address. And here it is right here, NTP server, type in the address, and that is where it will get its detailed information from. We can also see things like the association by doing a show NTP association or show NTP status. Basically, these will let us look at the address, the reference clock, the polling, the offsets, and all of the major details. The show NTP statistics will show us the stratum number as well as the reference and the frequency that it is actually dealing with. The big part here is we're looking at the precision of our time. Again, to set it, we would be doing NTP server, set the appropriate IP address, and then you can now look at the associations and the statuses. You'll notice here we're doing a nested NTP server, so instead of being the stratum 2 like it was before, we'll have a stratum 3 because we're now 3 hops away. And again, we definitely have a lab walking us through how to do all of this. Moving on, we have our SNMP, our Simple Network Management Protocol. And basically, SNMP was developed to allow administrators to manage the network and manage the nodes that are on the network, because as the network grows, the staff doesn't always grow. So the administrator's ability to manage those devices have to become a little bit more fluid, flexible, and a little easier. So with SNMP, that's how it's done. SNMP is an application layer protocol that does provide message formats for communications between a manager and the agent. The manager is going to be like a workstation. The agents are going to be the end devices. And the big thing is our SNMP systems as a whole have three main elements. The manager, that's going to be the main workstation. Our agents, those will be the managed nodes. And the MIB, the Management Information Base, MIB. The entire purpose of this is so that SNMP will define how the management information will be exchanged between the application, the manager, and the agents. The SNMP manager will pull the agents and query the MIBs for each of those agents using UDP port 161. The agent will send any updates or traps to the SNMP manager on UDP port 162. So SNMP uses UDP ports 161 and 162. So how does this work exactly? The SNMP manager is part of the management system, the NMS. The SNMP manager will collect information from the agents using GET actions. And they can change configurations by using SET actions. The agents will forward the information to a manager using traps. And we're going to go through some of this lingo a little bit later. The SNMP agent and MIB will reside on the client device. The MIBs store data about the device, the operational statistics, the available resources, the authentication ability, things of that nature. So what exactly does that mean? One of the biggest use cases that I've used SNMP for is like printer management. I may manage 50 printers throughout my organization. I can set SNMP to alert me on page count, paper count, toner levels. That way, as I start seeing that my devices are getting low on toner, I can get an alert and I can have replacement toner sent a little sooner than normal. That allows me to effectively manage my end devices. And I use printers as the example because realistically in an office setting, when there's a very small IT group or management team, the printers are probably one of the biggest things that will be reviewed and managed and reported on the most. If I need to update a router or a switch, yes, SNMP can do that as well. However, the amount of time that I'm going to use SNMP to manage a device like a router or a switch versus the amount of time that SNMP will be reporting on a printer, the printer is going to be used a much more regular basis. So being able to utilize the resource management and the resource tools for the printer is going to be extremely important. So let's look at our agents. They will reside on the managed device and they will collect and store information, and they will store it locally in the MIB. The manager will use the agent access information within that MIB. So we can do things like a GET request or a GET next request. They will retrieve values for very specific variables. Maybe we need to do a bulk. We need to get several pieces of information. We could also do responses. Responses basically reply to GET requests, GET next, and SET requests. And again, a SET request is something that will be changing a stored value. So GET will retrieve, SET will actually put a stored value in place. So what actually happens with these requests? Essentially, the agent will respond to the manager's request as followed. It will get an MIB variable. The agent will perform the function depending on whatever it's supposed to be doing. Then it will set the appropriate variable if that's what was required. So the first one would be obtaining information. The set will be actually setting the variables on the agents. So the agent trap. So a trap are unsolicited messages alerting the management station to a condition or an event on the network. The trap will be directed notifications, reducing the network and agent resources by eliminating the need of some pulling requests if an interface goes down. instead of the manager station having to pull the device will just send an update. Hey, my interface went down, assuming that's what was configured. There are multiple versions of SNMP. The common ones are version 1, version 2C, and version 3. Version 3 being the newest one. And version 3 uses username and authentication. It provides data protection using hashing algorithms, MD5 and SHA, and it will also encrypt using standard SSS, AES forms of encryption. 2C, it's more of a simple string, no real encryption. It does still have authentication methods, and it does provide for bulk retrieval options, but again, it's not as secure as our version 3. So version 1 and version 2 both use what's called a community string, and that controls the access to the MIB. So essentially, there are two types of ways for this to happen. When the community string is configured, it will have to authenticate access to the object, and then once it authenticates, it has two permissions, read-only and read-write. The read-only basically only allows access to the MIB variables, but don't allow for any modification. When you have the read-write option, this will provide the rewrite access to the object. So to be able to view or set the variables, the user must specify the appropriate community string for the level of access that is needed. For our MIB object IDs, those are normally called an OID, object ID. The OIDs uniquely identify managed objects. These MIB organize the OIDs based off of the appropriate RFC standard. So basically what ends up happening is, let's say we're managing a printer. Well, the printer is going to have multiple object IDs that are all of the sub-features of that device. So we can actually start managing certain areas of the printer, for example, based off of the OIDs. And the OIDs are actually built off of a hierarchy, and they're normally shown in a tree-like structure. The MIB tree for any given device will include branches with the appropriate variables. The RFCs will define some common public variables. Most devices will implement these MIB variables in an appropriate way. So here is an example. We could have an OSI, an org, a DoD, an internet, a private, enterprise, Cisco, and then we could have different local variables. Well, you'll notice these numbers are actually the tree-like structures. So here we have an OID belonging to Cisco. They are numbered as followed. iOS, that's given a 1. That feeds into the org, which is the second. I'm going to grab my pen. So here's our first number, our second number, third number, fourth number, fifth number, sixth number, and so forth. And these numbers correspond to our OID spots. And then once it passes 9, it will actually either go variables for local variables, interfaces, or other groups. Here's an example of us being able to see it. We have an SNMP GET request. We have our version. We have our community. We have an address. And we have the appropriate OID number. And again, we're assuming that we know what that OID number is. And that I'm going to explain in 1 second. The return will actually be an integer, and that will be a CPU value. So how do you get the OID numbers? Well, realistically, you're going to have to know the specific device and the settings for that device. They will help you define the appropriate OID information. I can honestly say this has been the most frustrating portion of dealing with SNMP, is building out the OID information, because sometimes these numbers are not as easy to guess or to use or to decipher as they should be. We definitely have a lab covering this as well. Moving on, we have our Syslog. First of all, Syslog will use UDP port 514. This is going to be sending information across the network, typically to a centrally logged server. If we have devices, we can have those devices forward their logs to the Syslog server. A Syslog server does provide 3 main functions. gather logging information for monitoring and troubleshooting. It gives us the ability to select the type of logging information that we want to be capturing. Also, it gives us the ability to specify the destination of the captured system log messages. Logs can come from the buffer of a device, the command line, the terminal line, or Syslog servers. So these are all very common destinations for the log information to end up. The device itself can generate logs from everywhere, from anywhere. But how are we reviewing that log information? How are we reviewing it? If we're on the device could have a log generated for the local device and put into memory. We could view the local log. If we're on the device via its terminal or through its console connection, we could see the log information there, or we can have, again, dump it to a log server. The important part is understanding the severity of the logs. There are 8 levels, 0 through 7. Normally this is not CCNA material. You don't need to memorize the levels. This is definitely something you have to memorize for CCNP. So each of the logs will have a very specific level. You can have a level 3 log, and that's going to be an error condition. Or maybe you only want to display level 4 and above. Well, you can do that. You can set what log message level are going to be actually sent and where you're going to do them. Our facilities, basically our device can generate logs based off of anything. Interface, the operating system, the protocols. Normally, if we turn on or turn down an interface, throughout our labs we've seen something similar to this. We have a link 3. It is up. The interface port channel has changed to the status up. Notice link 3, it's a level 3. How do we go ahead and configure things? Well, we've already looked at how to set up NPP. We've already looked at essential how to do our syslogs. The problem is our syslogs by default don't have timestamps. So we need to actually be able to set up our timestamps. We do that by issuing a service timestamp log date time from the global configuration. That dictates that we are going to have timestamps on our logs. Alright, moving on. Let's go ahead and let's talk about router and switch file maintenance. First of all, Cisco has what's known as an IFS, the Cisco iOS file system. We can do a lookup basically by going to the exec mode and typing show file system. As long as there's content there, we should be able to see content that is shown on the system. This is what is shown for a Cisco 4221. However, anything in the flash memory or on the disk, if there's directories or anything like that, should be here. If we want to navigate, we could do a dir, and that will show us our directories. That will show us the content. You can see which action items are directories, and you can see the permissions that are given: read, write, execute. We can navigate by doing our CD and the appropriate directory. We can also see our working directory by PWD, or present working directory. So pretty common CLI commands. Again, if we're wanting to do the same thing on a switch, we could do a show file system from a switch, and you can see what files are there. This actually is extremely important when you purchase a new switch and you're curious if there is any VLAN data that is still on the switch, because there will be a VLAN.dat file here if there is. So how do you back up certain commands? How do you back up certain devices? Well, you can actually do a show run, and you can log that information and you can export it. You'd have to do some cleanup, though, things like encrypted passwords, stuff like that would have to be verified, but this is definitely a way to back up a configuration of a device. If you're doing it, again, go to the terminal, do a show run, copy all the text out of it, and you should be good. However, that's one way. You can also do a dump from the running config to a TFTP server. Basically, what you would do is copy running config, TFTP, hit enter. It will ask you the host address. It will give you the ability to put a name in, and then as long as it is set up, it will copy over. Again, we should have labs covering TFTP, and we do. We can also have USB ports on more current devices. For example, the 4321 has USB connectivity, so you can actually plug in a flash drive. How do you back it up to a flash drive? Copy running config, USB flash 0, and you can dump the configuration to a flash drive that way. Again, if you want to view the contents of a flash drive that's plugged in, you would do directory, give it the location or the path to the directory that you want to look at. You could also change directories to that if you wished, and then you could see the content of the files that way. Password recovery procedure. This is always the good one. This is actually one of the ones that is extremely important. Essentially, there are 6 main steps for password recovery. First, enter ROM on mode. You need to change the configuration of a registry. From there, it will reboot and you can load a startup config. You basically load the startup config to the running config. You can then see the password, or you have the ability to remove the password. That's step 4. You save the running config to the startup config, reload the device, password reset or recovered. Alright, so that was a quick rundown. So let's go a little slower. First of all, when you're booting the device, it's a certain key button combo that you're going to have to hit. This will allow the device to enter the ROM on mode. It will actually boot to a ROM on prompt, so ROM on TAC 1. From there, we need to configure the register to be 0x2142, and we do that by doing a config reg 0x2142. Hit enter. That will get you into a ROM on 2. From there, you would hit reset. The register that is set to 0x2142 basically says to load the starting config, or to load the device with just a standard config and give you access. From there, you would copy the startup config to the running config. That bypasses the password function. You'd be allowed to configure the terminal, and from there, you're at a global configuration. You can change the password. Once you change the password, you want to save it again, so a copy run start and reload the device. That is normally how you do it. However, one thing you definitely need to do is you need to reconfigure the registry with a config TAC registry to 0x2102. That's the normal registry mode and not the bypass mode. Load the device and then it will boot normally. If you do not reset the registry, it will keep bypassing the configuration file and load a blank config. We have a lab about backup files. We have a lab about configuring basic device emulation and restoring files. And we have a lab doing a lot more with TFTP. Our last major section is about iOS management. So how do we upgrade a device on a Cisco router? Well, with TFTP, we would back up the iOS. We would verify that we can communicate with the iOS where we're going to be storing that device. So if we're putting it on a TFTP server, we want to be able to ping the TFTP server. We also want to make sure that we can communicate with it. we always want to make a backup copy of the Cisco iOS device just in case something becomes corrupted. We have encountered this. I have encountered this. So you always want to make a backup copy just in case. Ping the server. Verify the appropriate image size. You could do a show flash if you need to. You would copy the image to the TFTP server. And from there, we can move forward. So how do we copy it from a local device to our TFTP server? You could do copy running config TFTP and then give it the appropriate information. That's how you copy it to the TFTP server. If we want to copy from the TFTP server, you would do a copy TFTP : // and from there it will ask you the IP address and the file name. From there you can reload. So let's say you do this process. Now you have two iOS devices, or two iOS config. You have two iOS files on your device. How do you configure it so that it will load the specific one you want? Well, you're going to have to tell the device to boot to the right iOS. So you'd be doing from the global configuration, use the boot system command. You would tell it it's a flash, and you'd give it the appropriate iOS file. I know it's an iOS, it's a configuration file, but it ends with a .bin. This will tell the device what file to load. Then save it, reload it, and it will load the new iOS. We have another lab talking about how to go through this, and that is it for this module. We talked about network discovery, verification, and management. We talked about some of the labs we are going to be going through. We talked about CDP. We talked about LLDP. We went through NTP, stratumums. We went through synchronization, clients, importance of time management, looking at Syslog, looking at Syslog timestamping, looking at SNMP, looking at the versions, looking at port numbers, looking at agents, looking at Syslog locations, looking at what could be logged, looking at how to break down a log, looking at the severity levels. Then we looked at the file systems. Then we looked about how to back up files and configurations to and from a TFTP server and a USB device. And that is it for this chapter. Thank you. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.